Last section of 4.6. Sketch the curve of f if f prime of x equal to x squared minus 2x times x minus 5 to the power 2. Notice f is not given, so you really can't put points on the graph unless the points were given, the y value for the points were given. But you can completely tell me the shape of the graph, and that's the beauty of the derivatives and second derivatives. And so the first derivative is given, and I need to use the second derivative to also find values. But let's begin with this. Domain is negative infinity to infinity because it's the function is basically differentiable everywhere, and you can say that the domain has to be continuous everywhere, and so then asymptote's none because we have a polynomial. If you want to take the second derivative and simplify it and use the first derivative, so what does first derivative give me? First derivative gives me x equal to 0 right here, x equal to 2, and it gives me x equal to 5. And the second derivative gives me x equal to the values that you get from solving this quadratic equation, and x equal to 5. So x equal to 5 is in both points of interest, and then you get these two values, approximate values, for f double prime equal to 0. And so when I'm again, it's a polynomial over here, and I can see this is the f prime, right? And I can see how the sign changes. It's quadratic, polynomial of degree 4, and the leading coefficient is positive, so I get positive on both sides. And then as I pass through x equal to 0, sign has to change. That's passing x equal to 2, sign has to change because odd degree. At x equal to 5, sign doesn't have to change because the degree, the order of the root is even. And then I'll put in the values for f double prime also, and with the same routine I get the signs for that, and then I end up with this shape. And again, here I have it's going positive way, so I have to have this shape. This one is negative going down, and that's negative, so I get this shape. Over here, negative for the tangent line and positive for, and so on and so forth. And you find the local min and local max, and there's no global min or max for this one. And then you kind of graph this. What we did here is that we just fixed one of the y values, and then we went with the derivative, and we draw a picture of the function. And so what happens is that if you can shift this up or shift this down, and it would be the graph of the function anyway. Right now, like at this point could be up here, and so everything has to be shifted up, or over here everything shift down because the y values were not given to me. But also I can also draw the shape without the y values in this way, just placing it somewhere, and it works that way. And we're done.